Hello, we are SC04 Group 1, and in this video, we will be explaining our 2D project. For task 1, we aim to predict COVID-19 deaths that will occur in 14 days' time based on the studies of our chosen dataset. Before we begin, we will import the necessary libraries and recreate the functions we have learnt in class to use in our regression. These functions include converting the data frame into NumPy array, plotting out our dataset, making predictions, and evaluating our models with different metrics. We start by reading our CSV as a data frame into Jupyter Notebook and read the column names. Based on our research, we extract the columns that we are interested in for filtering our data and for the regression. We now proceed to clean our data. We notice that some name strings in our location column are not country names, and so we remove them and check that all our countries are legitimate. Through our research, we believe that countries with similar Human Development Index, or HDI, will behave similarly with respect to COVID-19 deaths. As our group aims to group these countries by their HDI, we filter more countries by finding only those with an HDI value. We move on from here assuming that all empty values are zeros, as the data for those days were not recorded. We also created a new column in which we shifted our new death values by 14 observations to signify the new deaths in 14 days. We are not concerned with the shifting edge numbers out of the country's data, as we are focused on filtering our data further by dates. Although many countries' data have dates from February 2020 to November 2021, we will only look at dates from July 2020 to June 2021. Hence, the 14 edge dates are not important. As all countries' populations are of different scales, we will use our features as percentages of their respective populations to level the scale across our features. We now group our countries by HDI and remove any country that has less than 365 observations, as this signifies that they have less than a year's worth of data. We also include a day number column to be used in our regression. As such, we have 3 HDI groups of low, medium, and high, and these 3 groups will have a linear regression model each. We begin our regression for each HDI group. The metrics we use to evaluate our models are the adjusted R-square and the root mean square error, or the RMSE. We also plot the relationships between features in the pair plot and plot our predictions. After plotting, we analyzed our results and found ways to improve our models. Our results show that we are able to detect trends based on the features we are given, albeit not 100% of the time. That is the end for task 1.
So next I'll be speaking about task 2. Our problem statement is how might we optimize the workload of healthcare workers in the USA by predicting the percentage occupancy of hospitals of individual states. So the idea here is that what we want to do is take the combined percentage occupancy of all US hospitals as our target. So in finding out this percentage occupancy number, we were able to have a good idea of how many healthcare workers we would need at any one point of time. So a total of 4 datasets will be used for this task 2. We have found data for number of new cases, number of new deaths, vaccination rates, number of patients who are intubated and on ventilators, as well as data for the number of hospitals being used by COVID-19 patients at any one point of time. So as mentioned before, our target has been set to the percentage occupancy of COVID-19 patients. So predicting this value is useful as it will give governments and hospitals a better idea of how many healthcare personnel they needed. In terms of features, our concept was having features that would be able to account for people being admitted to hospitals as well as people being discharged from hospitals. So we have 2 factors for people being admitted, namely the number of new cases as well as vaccination rates. We also have 2 factors affecting people who are being discharged from the hospital. So one of them is death rate and the second is the percentage of patients being on intubator or on ventilator. So this metric where patients are on intubators or on ventilator suggests the severity of the cases that a hospital has. So for example, if we have a high percentage of patients who are intubated or on ventilator, we can expect that maybe those patients would stay in the hospital longer as they would need more time to recover. So because we're using multiple data sets for our task 2, we took extra care in making sure that all of them will be merged properly. For example, in some of the data sets, the data is actually split by state. So what we have done is that we've sorted the data by date and aggregated them by state. This allows us to essentially get the total US value for that certain day. On top of this, we had to merge multiple data frames as they will have to access different data sets. The model being used here is a multilinear regression model with the 4 features that I mentioned above to predict our target. So of course the data is being used on the country level scale, but what we have done is that we've converted them to percentage values. So what this will allow for is essentially that if we had a smaller data set that did not cover the whole country, we will still be able to use this same model because of the percentage values scaling the values accordingly. We have used the gradient descent method that we've learned in class to obtain our beta values. Finally, we evaluate our model. Here are some of the plots that we plot our features against the target value, comparing the predicted and actual values. We have also calculated adjusted R-square scores as well as mean square error. Adjusted R-square is a more accurate indicator than R-square as it accounts for more features being added, which could increase the R-square value unnecessarily. To make improvements to our model, we remove outlier values, as these values could negatively impact the predictions that our model was making. In removing these values, we successfully reduced our root mean square error. However, our R-square value also saw a slight decrease.